Hi everybody, this is Tor Storley and I am back with another video. This is the fourth video in this series and I always promise that it's going to be a short video, but this time I think it will be. So with any further ado, let's just continue our saga into DuckDB, a deeper dive. So I'm going to open up DuckDB, the CLI. One thing I want to show in this video is some joins. And I also want to show you how you can use a recursive hierarchy query. So in order to do that, I need to set it up. So what I'm going to do is I'm actually going to use a demo database that SQLite, which is a transactional database, is using. So if you look at my screen here, you can see that it's calling on this Chinook database. You can see I open in PDF. There is a SQLite database that I use as a sample database for SQLite called Chinook. And it basically deals with records or tracks and stuff like that. So music, in other words. So when I looked at this thing, I said, you know, maybe this employees table might be interesting. Now, it's a very small little table because there's not a lot of employees, but it will serve as a purpose of demonstrating what I want to show you. So let's close this. I'm going to be working on this employees table here. I'm in DuckDB, and in order to open a foreign database like this into DuckDB, you can still use this .open, and it will just make it into a DuckDB database. So as you can see, it ran. This Chinook DB is now open, and what I can do is I can run my regular commands. So here's my show tables. As you can see, these are the tables we just looked at in that PDF file. And the one I'm interested in, obviously, is this employees table. Okay, now what I can do then is I can see, okay, what does that table look like? What does the data look like? Well, let me just do a from employees limit 5. So again, concise syntax from DuckDB, kind of nice way of doing it. I'm just want to see 5 records. Okay, so here they came back, but notice I don't see all the columns in this table, and I like to know what they are in case I want to query them. Okay, that's 5 records. So let me see if I can maybe fix this a little bit. And again, goes back to our previous video. You do a mode line, and then you can simply do a from again. But this time I don't need 5 records. I just want to see maybe a couple so I can get an idea of what it looks like. So here they are. So these are the fields: employee ID, last name, first name, title, reports to, and so forth. Notice this first one here is blank. That means it's probably the top guy, meaning the general manager here, Andrew Adams. So in many ways, employee tables are typically, the top guy usually have a null value because he doesn't report to anybody. They report to him. So that's why they put a null in here typically. Notice the second guy here, Edwards, or I'm sorry, the gal, I should say maybe, or to be more proper, I should say, the second woman is Nancy Edwards. She reports to Andrew, as you can see, number 1, because that's his employee ID. Okay, so now I got an idea of what it looks like. It looks like they are in Canada, and I don't know how fake this data is or not, or if it's based on something else, but whatever it is, we're going to be working with this particular one. All right, so what do I want to do then? What do I want to show you? Well, I want to actually run a query here that is going to basically query out a hierarchy. So let me set the mode back again so we can get it back in the box format. So mode, and I'm going to say box like this. Okay, so what I did was, and keep an eye on this records above here when you read this query. So I'm going to paste my query in. This is what's called a recursive query. Notice I'm using a CTE, a common table expression, but I use a keyword recursive. This will optimize this query technique within DuckDB. Now DuckDB, I'm not sure if it's written in C or C++, but it's very effective, it's very efficient. And I don't know if this has a specific meaning or not, or if you could create a query without the word recursive and it'll still work fine. I don't know. But anyways, this is the way they suggest you do it. So with recursive, give it an alias or name, and then pass in some parameters if you want to. Now, what I don't like about this particular method is that it produces a list. All the examples I've seen produces lists. And when I did this, I wrote my own queries in Oracle doing the same thing as you see here. Same technique, but you could pass in whoever you wanted and they will find your downstream hierarchy or upstream hierarchy. I also, in SQL Server, I used hierarchy ID methods for SQL Server queries. But this particular one here produces simply a list. So I don't know if there's other ways of doing it, but it seems a little limited to me. But anyways, I just follow whatever the examples that give you are, and this is what I came up with for this particular database. So notice there is a starting query, and the reason you have to have a start is because you got to find the top guy first. And of course, we know who the top guy is. That's Andrew. He has a null. He doesn't report to anybody, so you can see that here. Then you simply union it all, and as you work your way, you traverse your way down the ranks here, you will keep adding new people if you find them. And the way you find them is where you look for the employees table, which is this you see above, where they report to is equal to this new query we generated up here, which is called emp hierarchy, and you base it on the employee ID. Okay, so I want to first run it with King, as you can see here. So when it ran right away, and notice it produced a list of who is who. Notice King reports to Mitchell and Mitchell reports to Adams, okay? So if you look at it, here's the output. King, which is down here, reports to Mitchell because Mitchell is number 6. So ID 6 is Mitchell. So King reports to Mitchell, and Mitchell reports to number 1, which is Adams, as you can see. So it produces this path here for who is reporting to whom. Okay, and we could test that again. We can try this last person here, Callahan, and see what that does. And now when I run this, you can see Callahan, which is here. It reports to number 6, which is Mitchell, which you can see here. And Mitchell, of course, reports to Adams. So again, it just shows you a recursive hierarchy query you can use in DuckDB. It's another nice feature in DuckDB. It's kind of hard to understand this, but it's called a positional join. Now, what is a positional join? Well, much like, remember DuckDB has been, they started with R and tried to cover that, R, the programming, and make data available there. And then it branched out and did more and more and more. So eventually you get to Python. And in Python, if you know Python, there's something called pandas, the data frames. And in pandas data frame, each record has an index. So it's positional index. So the first record has an index, the second record has an index, and so forth. So I'm guessing here, but I assume they based it on that kind of logic, because in pandas, you can use positional referencing. And what they did here in DuckDB, they created a join that is positional. So if you look at my screen here, you can see that it has 2 CSV files. They have an ID and a column called letter. I just made this up. I try to make it simple so you can follow it. In the first one here, which I call CTE A CSV, and the second one here, this one, is called CTE B CSV. Now, the reason I use those names is because I'm going to make a common table expression out of each one of these. So I just named it accordingly. So if you look at it, this one is an order. It has 1 is A, 2 is B, 3 is C, and so forth. Now this one I purposely made not in order, because what I want to show you is the positional referencing. So notice the first reference here is 4A. So the first position, which reads number 2 here because I got the headers, but 4A is the first position, 2B is the second position, and so on. So the idea here is to join this positionally in DuckDB. What will that look like? Well, let's go back to DuckDB and take a look and see what it looks like. I select from this first CSV file here, the CTEA, and then I select from the second one, the CTEB, as you can see. And what I do, notice down here, I'm querying out all the CTA letters and IDs and the CTEB IDs and letters. But in order to show this off, so it doesn't just repeat what you see in the file, I force an order by here. Notice this says order by CTEB ID. So what does that mean? Well, when I run it, notice what happened. Because I order by CTEB ID, this one, it will be in order. So 1 will be C, 2 will be B, because remember, that's the way I wrote it in. There was letters. But because I sorted this one gets sorted too. So it matches each row, and that's the beauty of it. Notice this one is totally out of order now because it's positionally joined with the CTEB ID, which has been sorted. So I just wanted to show you this, and I'm not going to spend too much time because, you know, you may find this useful. For example, somebody running race or something, and people are running different speeds and then they come in at different times, but you just record when they came in and on something like that. But you want to match it with something else later. Well, if it's positionally like this, you might be able to match it according to how they come in, but it doesn't necessarily mean it's going to be sorted 1, 2, 3, 4, and so forth. The one join that I want to show next is something called an anti-join. So what is an anti-join? Well, I created some data here. So let me paste that in. An anti-join means that you're going to get all the records from the left-hand side of your query, the left table, if you will, that is not in the other table. So notice I'm creating a CTEA and a CTEB. And then I say select 1, 3, 4, 6. And here I'm saying select 2, 3, 4, 7. So there is a difference here, 1 and 6, and then you have 2 and 7. 3 and 4 are the same. So what I want to do is I want to anti-join this. As you can see here, I'm using this anti-join syntax down here. And I want all the records that does not exist in CTEB to show up that comes from CTEA. So in other words, I don't expect to see 3 and 4, but I expect to see 1 and 6. I'm not going to see 2 and 7 because that's not the left table. So when I run this, as you can see, 1 and 6 came 1 and 6. So that's what's called an anti-join. It breaks every record from the left-hand side table that is not in the right-hand side table. Now, there's another join too you can use called a semi-join. So let me copy my code for that one. Okay, so it ran right away without even telling me anything. So as you can see, the semi-join returns rows from the left table that has at least one match in the right table. And if you remember, 3 and 4 are present in both tables. So that's why it comes back with those. So it's not an anti-join, it's a semi-join. If you like this video, give me a like and consider subscribing to my channel. That'd be great. Have a great day, great night, wherever you happen to be in the world. We'll talk soon. Bye-bye.